In this video, I will explain what differentials are. So up to now, we have been viewing the expression dy dx as a single symbol for the derivative. Now actually, the symbols dy and dx in the expression are called differentials, and they can be separated. So these symbols can be used to view dy dx as the ratio of dy, which is the dependent variable, and dx, which is the independent variable. So dy dx equal to f prime of x can be written in differential form as dy equal to f prime of x and then times dx. This means that if we travel along the tangent line to a curve, then a change of dx units in the x produces a change of dy units in y. So what does this mean? So we need to probably take a look at the graph so you can understand how this all fits together. All right, so let's look at the geometric meaning of differentials. So let's say that we have a point P, x, and f of x. So I'll draw this over here. So we have this point P, and this is x, and this corresponding value is y, or f of x. So now let's say that we have a q value, and it's x plus delta x. That means I've moved over a little bit and a distance of delta x to get to my q value. So let's say this is x plus delta x, which means that this distance here is delta x. If this is x plus delta x, then when I go up to my function, then this will be f of x plus delta x. And so this point here is going to be my q value. All right, so we have these points P, and we have this point Q, which is moved over a little bit, and they're points on the graph of f of x. So let's call this y equals f of x. Now in this case, we're going to say that dx is equal to delta x. So the slope of the tangent line, which I'm going to call it PR, is the derivative f prime of x. So I'm going to draw a tangent line at P, and let's just call this point over here R. Now I want you to place R actually right above Q. So the slope of the tangent line PR is the derivative f prime of x. So dy represents the amount that the tangent line rises or falls. So that would be actually the distance from here to here. So this would be dy. And then the change, which is also the change in the linearization. Whereas delta y represents the amount the curve rises or falls. So dy is the change in the tangent line, but then delta y is actually the distance from here to here, and that's actually how much the curve is changing in the y direction. So we can say, so therefore delta y is equal to, so that equals, so since this is delta y, that would equal the difference between these two values. So that is f of x plus delta x, and then minus f of x, and that will give us delta y. So let's take a look at an example. So let's say that we have y equals xq. Find dy and delta y if x equals 2, and dx is equal to delta x, which is equal to 3. So finding dy is actually not that difficult. So if you think of it as dy dx equal to 3x squared, then we can say that dy is equal to 3x squared times dx. So dy is equal to 3 times 2 squared, and then dx is also equal to 3 here. And then we multiply all of that together, and we get 36. Now delta y remember, is a change. So it's f of x plus delta x minus f of x. So it's probably best to actually fill in these numbers. So we have x, which is 2, and then delta x, which is 3, and then minus f of x, so minus f of 2. So delta y is equal to f of 5 minus f of 2. So delta y is equal to 5 cubed, so we're going to plug in then 5 into the expression y, minus 2 cubed. So then delta y is equal to 125 minus 8, which is 117. So if you want to have an idea of what this looks like, let me draw a graph on the side here. So we know that the x cubed graph, it looks something like this. Okay, so I'm going to exaggerate it a little bit. And then it's asking you that x value is 2. So I'm going to say that's right here. Oh, and I actually exaggerated a little bit too much. Let me start this again. Okay, so I have my x value is 2, which is here. Okay, and that's my point P. And then I have my tangent line. Now notice my tangent line this time is underneath the graph, so it's a little bit different. So here is the number 5. So because it says x is 2, and then we're going to move over in a distance of 3. So this is my delta x, which is equal to 3. So that's going to be 5. And when I move up the graph, then my dy is actually this part here, which is makes sense, it's only 36. But then so I'm going to call this Q and call this R. So my delta y is this distance here, which is 117. So remember that the delta y is the change in the y direction on the curve, whereas dy is the change in the tangent line, so the vertical change in the tangent line. So dy is the vertical change in the tangent line, and delta y is the change in the graph.